Let's talk about dynamic instantiation of game objects in Unity. Dynamic instantiation refers to allocating the new object's memory during runtime. In our context, we want to create new game objects during gameplay. We will see how to do this through writing code instead of using the editor. We will only be touching the surface and implementing using a naive approach to keep this tutorial short and to the point. This means we won't be using common practices such as object pooling and object recycling. If any of you are interested in such design patterns, we can maybe take a look at that in the future. Our first goal is to create new game objects based on this projectile prefab. Now I'm going to go in play mode and give you a demonstration of what it's like to create new game objects during runtime. As we can see, they're animating, and this is dictated by this move script. Obviously, when you're actually playing a game, you don't have access to the editor for dragging and dropping. So let's see how to get this done in code. To start, here's a very simple component. All it does is that once awaken, creates a new game object by calling this spawn method defined right here. Now let's see what this implies. I have created a game object called projectile spawner. We won't be creating projectiles right away, but eventually, so let's name it that. And I will add my spawner component to it, and let's play. So we can see that it created this new game object, and it's a new empty game object. That means that this expression creates a new game object in the scene. Notice how I don't need to manually add the game object into the scene. The game object class's constructor will take care of that for us. Now, we can actually do more cool things with this, because this is very bare bones. And actually, once we've created a new game object, there's not much we can do with it. So, let's extend this a little bit, and note that new game object will obviously return a new game object type that we can store in a game object variable. So I will call this the spawned. And once I have the spawned, well, it's a game object like any other, and I can do pretty much whatever I want with it. I can get component, I can enable it, disable it, transform it, and I can also, well, add component and decide to add, why not, a light. Now let's take a second look at our project. So here we have projectile spawner creating a new game object that we see right here, and this game object has a light. While it's good to know how to create new and empty game objects during game time, that's not the most common practice. What we typically see is creating new game objects based on prefabs. So let's take a look at that. The first thing to notice is line 7. Here I expose a new member called object2spawn of type gameObject to the editor. And that implies that I can go here and just connect object2spawn to a prefab like projectile by dragging and dropping it. I can also click here and go in assets and select any prefab in my project. I can also go in scene and select any object in my hierarchy. Similarly, I can just drag and drop one. Now this is great because I'm connecting a game object, which can be a prefab or something that already exists in the scene, to this variable object2spawn. Let's move on. Here I just changed awake to start because that's actually more appropriate in my opinion, because I'm starting an action, I'm doing something, so I'm spawning an object. And here, what am I spawning? Well, notice how this line changed. So instead of spawn equaling a new game object, which we now know returns a new empty game object, I'm calling this method called Instantiate, which is available in every model behavior, and I simply give it object2spawn. And afterwards, I can add a component to that spawned. So I can add components not only on empty game objects, but on any game object. Now here I'm adding a rigid body. So let's take a look at what this gives us. Cool. So we got this projectile that got instantiated, and it has a rigid body attached to it. In addition to move script, which is actually part of the prefab. How about we take a look at this prefab? Now, we have a root game object with a transform and a move component, and a child game object called body with transform, mesh filter, mesh renderer, and mesh collider. What I want us to understand is that this prefab gets saved into a file called projectile.prefab. And we can actually open this file up because it's not a binary file, it's a text file. What do we find inside? Well, all the data concerning that prefab, all of its state, the state of the game objects within it, and also the state of the components in it. For example, this prefab has one game object called body, and this body has a transform, a mesh filter, a mesh renderer, and so on. We have another game object, this one's for the root game object, called projectile, with a transform with local position 000, for example, and also an added script that has a speed value, which is set to 2 currently. And yep, here we are. We can see local position 000 and speed 002. If I change this value, we are saving the prefab again, so we are writing to that text file. Now I don't see it updated here, so I'm just going to open it up one more time, and that has not been saved. Let's go back here. Or actually it has been saved. I forgot. We're going from 2 to 1. So there we go, 2 to 1. Let's do that experiment one more time. 0 to 5. Hey, here we are, 0 to 5. Perfect. Now, I can also play around in the opposite direction. Let's take the local position of the projectile game object and set it to 1000. So I'm going to save my change here, go back here, and there we are, 1000. So this is really cool because it permits us to understand how Unity represents objects, how it saves objects. And the process of saving the state of an object into a file, be it text or binary, is called serialization. And I have a hard time to pronounce that word, as you might have just noticed. Okay, so why is this so great? Well, if we can serialize an object, we can deserialize it, which is the inverse operation. So instead of taking an instance in memory and saving it as a file, we read a file and recreate the original instance and put it in memory. And that's exactly what this instantiate function does. So if I actually read the tooltip here, it says clones the object original, so that's the first parameter, and returns the clone. Now, some of you have definitely already heard the word clone in a programming context. It means taking a source game object or an original game object and recreating a perfect clone. So there are multiple ways to do so. One of them is deep copy, but the other technique is serializing and deserializing. So that's what we're actually doing here. This instantiate method is really just a deserialize method. So we give it essentially a text file, so the prefab file. It will read the state inside, interpret it, and reconstruct a game object and put it in the scene for us. So that's really cool. There are many overloads for the instantiate function. Before we take a look at them, I want to keep exploring this very simple one. Now notice how I've removed the code that added a rigid body on the spawned object, and I've also set the speed for the projectiles to a 0 vector. Now really notice how the position and rotation here are also 0 vectors. This will be important for a quick experiment. My projectile spawner is at position 110 and rotation 000. Now the spawn projectile, remember, it's positioned in the prefab was 0, 0, 0 for position and 0, 0, 0 for rotation. In other words, the location and orientation of my spawn projectile did not use the spawner position and rotation. And this makes sense. So if I take my position here and I change it a bit in the prefab, and I save, and I do my experiment one more time, I can see that the projectile that got spawned has the same position as the prefab. Why does this make so much sense? Well, we said that all we are doing here is cloning the prefab. So the prefab says that the state of the local position has 45 as a value for the Y component. And if you create a clone, well, the clone will have the same Y component value. There's no reason that this game object that got spawned should have the same position and orientation as the game object that created it. In this case, the projectile spawner. Now, this is good to understand, but it's not very practical in terms of game behavior. Let's say I have this Mega Buster, which represents a certain cannon. Now imagine that this cannon is attached to a player, and the player can move about and rotate. When the player will instantiate new projectiles, we want the projectiles to come out from the end of the cannon. We don't want to create projectiles while always at position 045, or actually 000. So we want to create these objects, these projectiles, at different locations and override the values here from the prefab's transform. Now that's when we start using different instantiate overloads. Take a look at this. I'm using the version of instantiate that requires two parameters, a game object and a transform. So just writing transform here, recall, this gives me a reference to the transform on the game object that contains a spawner component. In our case, the projectile spawner game object has our spawner component, so we're getting a reference to this instance of transform. What will this do? So my projectile clone still has local position 000, which is the local position written in the prefab. But now it's a child of the projectile spawner. So if the spawner moves, the projectile moves with it. If the spawner is here, and then I start the game, well, we can see that the projectile is there. It's at 000 relative to the spawner. So whatever you give here as transform, well, the game object that has this transform will become the parent of the spawn game object. If we look here, just give me a quick second, all right. If we look here, it says that we have a version that takes game object original and then transform parent. So don't look at the highlighted one in the list up here, look at this one, transform parent. In other words, we give it the transform of the game object that should become the parent to the newly instantiated game object. Now, that's pretty cool. However, in our case of creating projectiles coming out of a cannon, for example, this is not the best behavior. So take for granted that this projectile spawner is a cannon, and I'm in the game and the cannon is moving. So the cannon moves, let's say, to the right, because the cannon is attached to our player, and the player moves to the right, and whoa, we're moving the projectile with it. Okay, let's say that the player is rotating, the cannon on the player is rotating, and then the projectile gets rotated with it. Let's really see how this would look in game if I add back some speed to my projectile. Okay, so I can see my cannon is still here. My projectile is moving along. And the cannon rotates, and there goes my projectile with it. So you can create some cool effects with this. However, this is not really the kind of behavior we want in, well, the game that I've been describing. So let's look at other overloads to overcome this problem. What I have here is quite possibly the most popular variant of instantiate, the 3-parameter overloaded one. So object to spawn stays the same. Now I give it a position and I give it a quaternion. So this is a rotation, an orientation. Quaternions are used to represent rotations internally. I understand that here what we see is a vector 3, so x, y, z. But in reality, this is just a different, more accessible way of displaying and modifying rotations. But under the hood, what we're really using in our computations are quaternions, because they're way more optimal and they actually solve a common issue called gimbal lock that 3D data structures can't solve. So if you actually want to have really robust and complete rotations in 3D space, you need a 4D object, like a quaternion. Now, enough about linear algebra. All you need to know is that quaternion.identity is equivalent to your 0, 0, 0, XYZ Euler rotation. And if you want to give an Euler rotation that we typically use, we can just write quaternion.Euler and give it a rotation like this. And this function will return a constructed quaternion for us. So we never really need to truly understand how quaternions work internally or computationally. We can stay with something that's really accessible, thus the Euler angles. Now, so quaternion.identity, let's keep things simple and let's take a look at what this code does. Now, my prefab hasn't changed, but my object that got cloned is now at position -500. And here we are, -500. So let's just try one other thing, because this information is quite incomplete. Yeah, it's at -500, but is that world or local? Here we can't really know, because this projectile isn't a child of any other game object. So local and world space are equivalent. So there's actually a 4-parameter version of this where I can just give it a parent transform, just like in the previous example. Now let's try this again. And okay, things are quite different now, aren't they? So here my spawner is at 119.44. And this projectile is at -6, -1, -9.44. So what's going on here? Well, I said I want -5 on x. So why don't I have -5 here? Well, remember, this is local. So this is -6 relative to its parent. So what happens if my projectile spawner is at x = 1 in world space, and I tell Unity to create a new game object at -5 world space for the x component? Well, that means for this projectile to be at -5 world space, I need to do -6 from my spawner. So I need to start at this point and move to the left here by 6 units, so -6, to arrive at world coordinate 5 on the x-axis. And similar things happen for y and the last component here. So I want to create my game object at world coordinate 0 for the y component. Same goes for the z component. That means if I'm at 1, I gotta do -1. And if I'm at 9.44, I gotta do minus 9.44. Let's do one more thing here. As I mentioned, quaternion.Euler 90, 0, 0. Let's try that. And I'm going to give a rotation of 90 here on my spawner. Okay, let's try that again. And take a look here. My rotation, my local rotation is at 0. Since I was already at 90, to be at 90 in world space, I don't need to do any extra rotation. So I have 0 here. Now, all this to say that this position value is a world space position. This means I want you to create the spawn game object at this location. The origin of the created object will be at this location in the world. And this gives a world rotation, so not local rotation. Here's our final solution. Notice that I've removed the transform at the end, so we only have 3 parameters. We don't want the spawn game objects to become children of the spawner attached game object. And instead of giving it a hard-coded position, I'm just giving it the world position of the game object that contains this component. So the game object that has a spawner, for example here, our projectile spawner. And again, note, this is not local position, this is world position. Similarly, here I'm giving it transform.rotation and not local rotation. So my game object that will be spawned will have the same rotation as the spawner. Now let's take a look at this projectile prefab real quick, just so we can understand that this move component is on the projectile game object and not on the body. This is because the body's orientation has its z-axis going down like this, but we want to move the projectile forward like this in our code. Let's take a look at that code. So we can see here that we want to move this game object along its local z-axis. Not this z-axis here, but we want our script to be here to move along this blue line. Just to be really explicit here, I'm saying that the translation, so this transform.translate, is relative to space.self, so in local space. Now let's go back to our experiment and test it out. Okay, I'm just going to stop this and let's look at what we've got. So here's my spawner and here's my projectile. Let's carry on. Okay, pause it again. Now here's my projectile and here's my spawn location. Let's do another test. Let's take the spawner. I'm going to move it around. Let's say I'm going to put it maybe here, and I'm going to change its orientation again. Let's say maybe like this. Okay, so we see this orientation has the forward vector pointing over here. Let's start. Now I will pause, and I can see that my projectile spawner is here, and here's my projectile. Let's carry on. So I can see that I'm getting the behavior that I wanted. Let's do an example with this Mega Buster cannon I created. Let's take a look at the prefab and notice that it's not a very complicated prefab. It's just a bunch of primitives put together to create this illusion of a cannon. Now, what I really want to focus on, however, is this game object called exit point, which is an empty game object, meaning it only has a transform. And this game object, well, its purpose is to take this transform and use this transform as our spawning location in our code. So I want my projectiles to appear here. I don't want to use this transform's position. I don't want them to come out here, nor here, nor there. I want them at the exit point. So all I have to do now is take my Mega Buster, and I can decide to go on my exit point, add my spawner, and here give it my projectile prefab. So let's take a look at this. So we can see that it indeed came out here. Let's do it again. There it is. However, notice one small issue. The projectile, well, its origin is in the center. That means when it gets spawned, it actually gets spawned like this, because this exit point and this projectile should both have the exact same transform information in terms of world space. Obviously here we're seeing it in local space. So the values don't match up, but they should be at the same position. So this is what happens the moment this projectile gets instantiated. It will appear like this. Now this might not be a problem, but it could potentially be a problem if we're thinking about collision detection. What happens if we create this game object inside this other game object? Will we have collision issues? Maybe not, maybe yes. We can program accordingly. But what I want to show you now is how to get the projectile to be like this once it gets spawned. Now, the easiest way to do so is just to go and fix our projectile prefab. So we can actually see that the origin is set in the middle here. I can just take this body and I will fix that. So I should put 1 here actually. And there we go. That means that the projectile will now spawn from this point. So it doesn't do anything really bad for our rotations either. So think of this pivot point as our exit point. All right. Now let's try this again. I'm actually just going to move the camera a bit so we can see what's happening. So give me a moment to do that. Okay, I'm going to take the Mega Buster and just transform it a little bit. There we go. Now let's take a look. And we could really see that it spawned here and not inside the cannon. Okay, now one more thing. I put the spawner on the exit point. Now imagine that this hierarchy for the Mega Buster or any other cannon was a bit more complex. Having to navigate through it to go find this component isn't all that fun or intuitive or even practical. What is spawning in terms of, no, conceptually? Well, it's the Mega Buster that's spawning. This is the cannon, which is creating new projectiles. It's not as intuitive to say that the exit point is the spawner per se. I find it better to say that, well, the Mega Buster is the spawner, so this Mega Buster should be the one having the component. Okay, so spawner here. Let's plug this back in. But now we have an issue that this is the position we're giving, right? This is the transform that will be used in the code here, and no longer this transform. Well, one thing I like to do is just add more flexibility to our script. So serialize field, private transform, And I'll call this exit transform. And this will allow me to just connect any transform I want. So exit transform, I will take my object in the scene, my Mega Buster here, has an exit point. There we go. So now we've connected everything up. And oops, I'm not actually getting what I wanted because I forgot to change this. So exit transform and exit transform once again. There we go. One more time. All right. Now I won't do it here for time, but let's say that this game object was moving in time and was rotating in time, and we could shoot projectiles at multiple time steps. So not just one projectile at the beginning, but let's say we can shoot 100 of them at every second interval. Well, our code is already ready for that. So we're always going to go get, for each spawn, the new values of position and rotation. So it's auto-updated, in other words. You know what? I changed my mind. I actually do want to show you guys an example. So here we go. My Mega Buster will be spinning, and we can see that we are creating projectiles appropriately. I can change its position during game time, and also its rotation. How is this accomplished? Well, I have one script, here it's called timer, that calls the spawn method in the spawner component at every 0.3 seconds. To allow this, I had to change private to public for my spawn function, and just for cleaning things up, I've written this down on one line. That's all. We can use what we just learned to create interesting effects. For example, I've changed my projectile here to principally be nothing more than a trail renderer particle effect, and I've put transform back here in my instantiate function, just for fun, to get the following interesting visual effect. This particular example is quite dangerous, however, because we never stop spawning projectiles. We add more and more pressure on our rendering, and we also allocate more and more memory. So we will eventually run into hardware limitations. If you're interested in creating effects like this, but do not want to encounter eventually the problems, you have to clean this up. You have to destroy some game objects over time. The best thing would be to use object pooling and object recycling. So you can look at that on your own time if you so desire.